Hello, welcome to my space station. Today, let's learn about the expansion of the universe. Now, when we all are taught in school or when we see something online that after the Big Bang, the universe started expanding, one thought that comes to mind is there any way to prove this? Now, the Big Bang can slightly be proven, definitely. There's the cosmic microwave background. There is the fact that the universe cannot come from nothing, there has to be something. And there are different evidences present throughout the universe, such as the early stars and the early black holes, which point towards that there was some sort of explosion or some sort of thing towards the early stages of the universe that caused it to form. Now, after the explosion, the logical explanation is that that explosion would have started to expand, and that's one of the first proofs that the universe is expanding. But one issue with this is that it's possible that the universe might stop expanding. Now, here's what we get into a little bit of complicated stuff. Now, the universe definitely can expand, but is there a force slowing it down? Now, we have no idea if there is anything outside of our observable universe. Probably there is the unobservable universe, okay, that whose light has not yet reached us. Outside of that, outside of the universe completely, we don't know what there is. If there's a multiverse, then there's a multiverse. If there's different stuff, then we don't know. So the main question comes to mind, is there a force that is stopping the expansion of the universe, which might cause it to stop expanding in the close future? The answer is yes. It's the force we are most familiar with, gravity. Just like how gravity prevents a star from tries to prevent a star from going supernova, just like how gravity constantly opposes the expansion, like opposes the star's nuclear fission, gravity is opposing the expansion of the universe. Now, what is causing the universe to expand in the first place? Now, one of these phenomena is called dark energy. You may have heard of the dark energy dark matter combo. Now, dark energy is mostly prominent in the areas of space where there is less matter, that mostly in cosmic voids. Now, when space is opened up, as the universe is expanding, right? Now, there's more space created for the galaxies and all the stars to move to, and that is where dark matter, dark energy is more present, and that opposes gravity. It tries to expand the universe further. Now, there is one consequence of this, that the galaxies, the stars, the black holes are now moving away from us very fast relative to us. So there's this formula devised by Edwin Hubble in 1929. The formula basically states that to find the velocity of how far a galaxy is moving, how fast a galaxy is moving away from us, we take the speed of the expansion of the universe and then multiply it by the distance between us and the galaxy. This is assuming that the universe is expanding, and this formula works really well. It's V is equal to HO, which is Hubble's constant, times D, which is distance. Now, in these kind of formulas, the units are different. And here, the velocity, radial velocity, is measured in kilometers per second. The Hubble's constant is measured in kilometers per second per megaparsec. Now, in space, where the distances are very huge, a light year is not sufficient, right? You can take the Milky Way, it's like 100,000 light years in diameter. And other than the Milky Way, there's many, many big galaxies, right? So measuring them, the distances between them would be huge. They won't be comprehensible. So we use a different unit called a megaparsec. 1 megaparsec is equal to 3.68 million light years is unit for distance. So in this equation, D is measured in megaparsec, and so Hubble constant combine these two. So how this is able to prove that the universe is expanding is that this shows us that this galaxy is moving away from us very fast, and the only explanation to that is that there's being more space created for it to move into, and more space created, that means that the expansion of the universe is taking place. So these are one of the main proofs for the expansion of the universe. Now, there are different ways. Many different people have made different assumptions on why it's expanding. Some assumptions are that there are different forces, and some assumptions are that there's a multiverse. So there are many different assumptions, and this Hubble's constant and the dark energy, and there's another way is using Doppler's effect. Now, I've discussed this in a previous video. The Doppler's effect is especially useful by telling us that okay, this galaxy is in redshift, and this galaxy is in redshift, meaning that these are again moving very fast away from us, and this can be further proven by the Hubble's constant. So this was all for today. I hope you understood, and I hope you're convinced that the universe is expanding. And I'll see you all next time. Bye bye.